Okay, so now it's your turn to have a go. So differentiate the following. Given y equals this thing here, find dy by dx. Okay, so press pause and have a go. Okay, so to do this here, visualize this whole thing here as one fraction multiplying another fraction, and then this block here, visualize it as x to the power of minus one. So from our section on indices, whenever you have x to the power of minus one, we don't really understand what it means to have a power of minus one, so we immediately jump to this. So now we're just working backwards. We are here and we're jumping back to here. Okay, so visualize this thing here as this. You could use a quotient rule on this, but it turns out to be easier when you visualize it like this here. Okay, so now once it's in this form here, remember this thing here moves down. So it's basically this thing here times this fraction here, and then the power gets minused by one. So you can think of it as 2 minus 1, that would be to a power of 1, but then we don't bother writing to the power of 1. So remember, this gets multiplied down here. So you have this times 2, which will give you 6 over 5. Okay, well, if you differentiate this here, it will give you this. And then this thing here, remember, this thing here gets it gets multiplied down here. Well, minus times a minus 1. So that will give you a positive 1. Well, it will give you a positive. And then this minus here gets minus by 1. So that becomes to the power of minus 2. That will then give us this. Well, now it's just a matter of tidying up. Then this gets multiplied to the top. And then rewrite this as 1 over x squared. So that will give you this. Okay, so overall, your dy by dx will be this. Okay, next one here. Given that s equals blah 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 here, find ds by dt. Okay, so differentiate s with respect to t. It's pretty much the same process, but the way you write it will be ds by dt. Well, anyway, find ds by dt. Press pause and have a go. Okay, so to do this here, yeah, so this will get multiplied to the bottom here. So actually, sorry, visualize this thing here. Visualize this thing here as 4 times this block here. Okay, so basically, move this out here and then put a 1 in its place. So what I'm trying to say is this bit here, visualize it as 4 times this thing here. Well, this thing here is really t to the power of minus 2. Okay, so remember, we don't really understand what it means to have a power of a minus 2, so we immediately visualize 1 over t squared. Well, here we've got 1 over t squared. We're working backwards. Well, my point is visualize this bit here as this block times this block here, and then this block here becomes this. So you've got this times this here. Now it's nice and easy to differentiate. So once you're here, then you can just remember this thing gets multiplied downwards. So it would become 4 times minus 2, which would be minus 8 here, and then this minus 2 gets minus 1, so it will become a minus 3. And then this thing here is quite straightforward. It gets multiplied to the bottom, so it become a positive 12, and then the minus 3 itself becomes a minus 4. So when you try and differentiate this, it will give you this. And now it's just a matter of tidying up. You don't have to, but visualize it as a 12 times. So this bit here, visualize it as a 12 times a 1 over t to the power of 4. And then a 12 gets multiplied to the top, so it becomes this. Okay, and then this bit here, visualize it as this times this here. So that will then become 8, and then 1 over t to the power of 3. This 8 gets multiplied to the top. Okay, so it will become this. So this thing here, tidied up, will look like this. Okay, and the last one. hang on, last one here. Differentiate this here. Okay, differentiate this. Remember, this here is another form of the quotient rule, where if you want to differentiate this here, one thing over another, if you want to differentiate the numeral over the denominator, um, then you would keep the denominator the same. Okay, keep the denominator the same. It's pretty much the quotient rule. So if you want to differentiate one thing over the other, keep the denominator the same, and then differentiate the numerator. Okay, and then if you and then you take away, take away the numerator, keep that the same, and then differentiate the denominator, and then divide it all by the denominator squared. It's just another form of I think it's an easier form of the quotient rule. Well, anyway, given this here, find dy by dx. Okay, so this here is just to help you. So press pause and have a go. Okay, so to do this here, it, remember here you've got two parts. If you differentiate this here, it will give you a 2. Okay, and then this bit here is a complicated bit here. Oh, by the way, you could well, some of you might even try this. Try visualizing it like this. Hang on. This bit here, some of you might try this. 4 and then times times 3x squared minus 5 to the power of minus 1. You could try this here, but there's a, you see, if you have something like this, if you have 3x to the power of minus 2, then this is nice and easy to differentiate. But here, because you've got a minus 5 within this thing here, it's quite hard to differentiate. In the future, I will show you how you do that. But for the time being, use the quotient rule. You could try and when you try and differentiate this, you could try it that way. But learn to use the quotient rule for the time being. There is another way of doing it. Okay. Well, anyway, using the quotient rule will give you this here. Okay, and then it's just a matter of tidying up now. So 0 here times this whole thing here, that will give you nothing. And then this bit here will give you this, and then this here will give you this here. Don't forget this 2 here is from this bit here. Okay, so if you want to differentiate the whole thing here, then it will give you this. Okay, and then tidy up, it will give you this, and then take the minus out here. So that will then become this. Well, yeah, this thing here will then become this thing here. Basically, we're just taking this out. Okay.